Hello, and welcome to Digital Design Homework 3. And the task was to design and simulate a 4-bit full adder circuit. And we should implement the circuit with non-ready FA blocks. And that was, as I asked in the exercise group, it was only important in the last course as they used Cedar, which had um, ready blocks for full adders, and I think also um, our Logism Evolution should also have those. I don't know where they are, but Homework 4 also needed those. Um, no idea where is it. But yeah, I hope I find it for the Homework 4 whenever it is needed. So yeah, I thought this exercise would be um, most simple to start from the first block that is needed, which is a half adder. And the half adder can be used for simple calculations like 1 1 and 1, I mean like single bit um, calculations. So we have the A0 and the B0, and with this we can add 2 bits together. So if we have, for example, 0 plus 0, it is 0 for the both of these. And if I have either one of these 1, we get a 1, because 0 plus 1 is 1. But as we know from the calculations with bits, 1 plus 1 is 1, 0, and this is only a half adder, so we cannot show like two bits here. So we have the carry 1, and if they both are true, it goes to the carry out bit. And we can do this logic by simply having an XOR gate here. And what it does is it cannot be 1 if they both are true, only if the other one is true. And with the half adder, we can make the full adder. And it looks something, oh my god, something like this. And it looks a lot more complicated than just the half adder, but we can see that the half adder is still used in the full adder. And with this, we have the 2 bits here, but we also have the carry 1. And if we just put this to 1, the output is 1, 0, or 0, 1, as we have to read it from the bottom up. And let's make it more clear what we're handling here. B0, B1, and then this would be like the product or the sum. So yeah, but when we press this one, we can see where it goes. And for the full adder, we need 2 XOR gates, 2 AND gates, and an OR gate. And as we can see, 1 plus 1 is 1, 0. And let's fool around with the bottom one. And if we put this to 1, it should go just through both the XOR gates and be 1, 0. Yes. But if we put these both to 1, we can see that it changes, and this XOR gate blocks the signal here, and it blocks actually it doesn't use this, so it is only if this is used, the upper, the half adder. So we can try that out, and yeah, turns into 1 0 0. And if we turn this the 1, this blocks out the signal and it goes to the AND gate, and then from the AND gate into the OR gate, and as this is 1, it turns into 1. But if we put this also as 1, it goes straight through the XOR gate, like this. And we can see from this how the full adder works. And as we needed to do a 4-bit full adder, we need to extend this a little bit. And I hope I can just oh yeah. Let's change these up a bit. I mean 3, 3. And now we should have a 4-bit full adder. Let's just delete that, delete that, and from here to here, and from here to here. And let's change this to 4-bit full adder. There's a dash there. So the task was to try out a simple input of 1011 plus 1001. So let's try that. Let's put everything to 0 and 1 0. I mean, we have to do it from the bottom up, right? 1 0 1 1 plus 1 0 0 1, and we get the answer, which is 1 0 1 0 0. And let's see if that is correct. So we add this one and it carries out here. So the third position, and then you add these together and it goes one up. Yeah, this should be correct. And then there was a second addition for optional numbers, not 0. Be sure to check that the totals are correct. So let's choose some arbitrary numbers which are different from the original ones. And let's calculate this before we try it out to check if we get the correct answer. So what this should make is the 1 carries here, so it's 1 0 0 0 1, if I have calculated it correctly. Now let's try turning on these. So 0 1 0 1 and 1 1 0 0. So we get the sum, which is 1 0 0 0 1. And yeah, that is correct. Or at least the number we also got. So this looks a lot more complicated than what we started with, which was the half adder. But as we can see, it is still used here. And I think it was a good learning process as I um, just tried out the 2-bit full adder or just the full adder, um, as it taught me how this works, and it's just add more of these to make a bigger adder. So yeah, thank you for watching.